Hello everyone, this is going to be our next video on scale factor. Last time was just laying the groundwork for what a scale factor is, and now we're going to actually look at a little bit more of a problem that you may see on your homework, for example, or your classwork perhaps, or maybe even a quiz or test. So let's look at these two. We're told that these two triangles are similar. This means similar. Similar. I wrote that really poorly. My bad. I don't know if that was any better. Okay, let's see. So we're told these are similar. So we need to find out what the corresponding parts are. Let's see, AB and DE are corresponding. AB and DE, because that's number one and number two. Let's see, BC and EF are corresponding. And so now what we can do is we can find a ratio. We can find a scale factor. So one of these is going to be really easy to find. So we want to find out what x is. We want to find out what x is. And so what we're going to do here is we're going to have to make a ratio, right? Now, I'm going to make it BC over EF because I want it to be a fraction. So it's going to be 28 over 20. What this is going to do is this ratio is actually my scale factor. Now, these numbers, they're a little big for me. They're a little too big for me. So what is this going to be? Well, we need to factor these down. Both of these are factors of 4. So this is going to be 5/7. Yep, 7/5. Okay, and so now we need to think, okay, we want to take 25 and make it into a bigger number. Right? Yes. We want to take 25 and turn it into a bigger number. So this is our scale factor. And so what we need to do now is think about, hey, will 25 times 7/5 give us a number greater than 25 or less than 25? Is 7/5 greater than 1 or less than 1? 7/5 is greater than 1. And so by multiplying 25 by 7/5 by our scale factor, we are going to effectively scale this segment proportionally to this value. Now, this is a very easy multiplication to do. So this is going to be 35. And that's what x is. So what did I do here? Well, I looked at the corresponding sides. Remember those? LOL, you thought those were gone. They're not. They never go away. Why would they? It's geometry. So I looked at the corresponding sides, and I just lined them up pretty easily. And then I took the two that had numbers, BC and EF, and I just made a fraction. Now, you may be wondering, well, Mr. Hissner, you could have made it EF over BC. This could have been 20 over 28. This could have been 5/7. And you're right, it could have been. But 5/7 is a number that's less than 1. And if I want to make a number bigger, and the number that I multiply that number by must be greater than 1. Now let's just look. We have 28. So let's look at how 28 goes to 20. If we have 28 times 5/7, you think that number's 20? Every time I did it, it was. Yep, 28 divided by 7 is 4. 4 times 5 is 20. And this is really easy math. It's really easy math. But what are we doing here? We're finding the scale factor, and then we're using that scale factor. We're finding the scale factor, the proportion, the ratio of corresponding sides. Scale factor is a ratio of corresponding sides. And then we're using that scale factor to determine our unknown value. Thanks for watching.